Right, so in this devlog, we're going to integrate a library called JSON, um, which is a C++. It's actually just a single file. It's a single header file that allows you to parse and write JSON files to your in your C++ application. Right, so it's actually quite easy to use. You just declare something like this, and then you push in some values, and it will automatically create the JSON structure for you. Okay, so this one was actually already integrated in the first version of the neural network. So we'll try to rewrite those components for this refactored version of the neural network. Some things to consider would be the structure as to the structure, how the structure will be defined and how it will be passed to the program for the different neural network parameters. One such example would probably be the topology of the network, right? We define the topology as a vector of integers, right? And then the order by which the numbers are pushed into the vector would correspond to the number of neurons in each layer, okay, in that particular order. Other things would be things like the learning rate, the momentum, and the bias can also be configured via a JSON file as well. So the idea is we can have a config. So I'm going to create a config directory here. And I'll say something like config.json. And for let's just do something simple, like the topology, for instance. Right. So we have a topology in JSON format that might look something like 3 to 3, for example. Right. So we'd like to read these values and try to see if they can be used in our program. Okay, so the first thing I'll do is I'll clean up this code, the main program. Okay, until this part. Okay, so remember we need to pass that topology to our constructor and then pass in the other parameters as well. Okay, so I need to read the JSON file from this point and then pass it to the to this variable topology before passing it to the neural network constructor. Okay, so I'm going to have some stuff here first. I'll say if it's not equal to 2, I'm expecting 2 arguments, then I should print the syntax for this program and exit. Okay, so we just have a print syntax here. Okay, and then it will say something like and then config file. Okay, so we have that print syntax function, and then if it doesn't have 2 arguments, then we say print syntax. Okay, let's try to compile this. Oops. Input was not declared. Alright, because we pass it here for the target as well. Oh yeah, we were initially training something. Okay, so I'll just comment this out first. Alright, so okay, we're gonna test this part. Okay, so if you simply run the program, okay, it will require the it will print out the syntax. Let's say something like this. Okay, there you go. So we need to pass in the syntax and say something like config.json, and then it will read that JSON file and then set up the parameters in our program. Alright. Okay, so the first thing we have to do is to be able to download this file. It's just a single header file, so it shouldn't be that it's hard to install. Where is that header file? I think it's under releases. Right, you just need this single header file, which actually makes it very convenient. They actually released a new version today, which is why I decided to create a video for this. Okay, let's check this out. So I have to copy it from downloads. And put it in my project. So I'll put it in the include directory. Okay, and then in the main part of the program, I'm gonna include it like so. Okay, I forgot how to use this. Let's check out documentation. Right, we do something like this using JSON. Right, from that namespace. Okay, then we can start using it as our config. So the nice thing about this particular library is that you actually have a structure called JSON. Right, it's like a data type. So we can say something like JSON config, for example, right? But actually a better way to use this would be something like hang on, let's refer to my original code. Right, if we pass in the argument, if we pass in the second argument as the location of the file path, we can actually read the file as a string, right? So we do that by the following. We have an if stream right here, actually after checking. Okay, so after we check if we have two arguments, if string, we call it config file, and then we take it from the second argument, we pass to the program, and then we create a new string out of it using the following syntax. Okay, we're going to use an iStream buff iterator. From the config file. Okay, and we can use the auto keyword for a variable called, let's say, let's name this config JSON, and we can call a function called parse, which parses the string into a proper structure with the proper data types. Okay, so if we're passing an array in a key, then it automatically turns, you can automatically cast it as a vector, for example, of numbers, which is what we need for topology. So for example, in the topology variable, we can just call something like config topology, right? So we're actually using the config variable, which is our JSON structure, as a sort of settings or configuration for our program, and then you just have a bunch of keywords that automatically gets transformed to the appropriate data type, in this case a vector of ints. So we can do the same thing for learning rate, momentum, and bias. We can have them as configs as well. Let's just try this one for now. Okay, let's just make sure we're actually reading the topology. Okay. Right. So we pass in config.json. Right. So we're reading 323. Okay. So we're sure that this one is actually working correctly. We'll do the same for learning rate, momentum, and bias. Okay, so we have a bunch of keys here. We say learning rate. Let's set it to 0.05. Momentum 1.0, and bias. Okay, so we have our configuration here, and then we can take it from our config settings right here. So config, learning rate, config momentum, and config bias. Okay, just make sure we're actually reading the values correctly, so let's print it out. Momentum, and bias. Of course, we have our topology right here. Let's compile this and see if it works. All right. Okay, so we'll be now using this JSON file to be able to parse a configuration, a JSON string, to serve as our configuration for our neural network. Okay. All right. Now that we can do that, next thing we'll do is to probably well, we can now instantiate our neural network and pass in the necessary values. I can't remember what these stand for. Let's check out the header file. Constructor. Okay, so we have hidden activation type, output activation type, cost function, bias, learning rate, and momentum. Okay, so this one is bias. This one is the learning rate, and this one is the momentum. Right? Okay, so we'd also want the training and the training part, right? We also want it to be from a file as well, instead of having to hard code everything as what we did in the previous iteration of this program. So we'll have that as our configuration as well. So we'll have the location of the training set as part of the configuration. So in our config file, we can say something like training data, and then the location of that training data. But of course, together with training, you also need label data, which is the one-to-one correspondence for the training data. Okay, so it will just be a simple CSV file, and but in order to read that file, let's go ahead and create a utility. I'm gonna name this miscellaneous HPP. I'm going to create a very simple class that will hold the utility for reading stuff from a CSV file. I don't think we need the matrix. Miscellaneous. Okay, and then so we have a static method here. We'll call it this one will return a vector of doubles, which will hold the training data. And let's just call it fetch CSV fetch data. Okay, wherein it will just need to pass a path, okay, of the file name that we'd like to read. Okay, so it's namespace properly, and then let's go ahead and create the implementation for this one. Okay, so just like math, we include the header file. And then this one returns a vector of doubles from miscellaneous fetch data string path. Okay, don't need the double here. Okay, so this will be a structure. Right, so okay, so in order to read that data, I'm going to open up an input stream from the path that we passed to it. We have a string line there, and we're going to read that CSV file. Okay, and then per line, we're going to create a vector of doubles to represent that. We're going to need a token, string token, that we parse from this strings from each line read. Okay, and then we have a string stream, so we can actually parse that. And we're going to parse it according to the comma delimiter. So we're actually expecting CSV in comma delimited format. Right, before pushing it back to the data. It's a very simple utility. All this really does is that it reads a file, okay, a string right there. We declare a line variable, which is our temporary variable that will represent each row in the file read. Our vector of doubles, okay, our token, string stream, and as long as we can read something from the string stream, we store it as a token according to the comma delimiter, which we push back to our vector of doubles. STOF will convert the string into a floating point number, which we can still store in the vector of doubles, and we return it as data. Okay, so you actually have a new file here called miscellaneous utility file, which we should also add in our compile process. Let's move it here. Let's see if we can compile this. Okay, so everything's working. Now I'll try to call it from our main program. Okay, of course we'll need the training data. In the form of a string. Rather, let's call this training file. And then labels file. Okay, so of course in our config, instead of saying training data, but actually we can call it training data. Label data. Let's make it consistent. I'll call this labels file, label data, training data, labels file. All right, can work for now. Okay, so I'd like this particular program to be a separate program, primarily just for training. And what it will do is that it will simply train a neural network according to these parameters, and then save the weights. Right, save the weights in the form of a JSON file as well, in which we can also read from. So what I'll do is I'll create a separate C++ file called train. Okay. And I'm basically gonna copy everything, put it there. Right, so this will be a self-contained program whose only purpose is to train a particular neural network according to some configuration. Okay. This way, if I needed to start to perform classification, then I can create a separate program just for that uses the same software, uses the same components just for classification. Okay, so we have a train.cpp file here, which we in turn add as an executable, okay, instead of an. Okay, so let's try this out. Let's see if we can compile this. Right, so we now have a new executable called train. Actually, let's also change this to train.json, so this will be primarily for the training file. Okay, so I'll create a new directory. I'll name this data. I'll say sample data.csv and sample labels.csv. Okay, so this one will be stored in, I'll use the absolute path for this. Sample data.csv. And for my label data, this will be absolute file path as well. Okay, so for example, we can have a bunch of numbers here. Let's say 0.5. Some variations. Right, just for example, right? So we have a bunch of data here, and then for our label data, it will just be something like 1, 0, 1. Okay, and our topology will be, okay, so we have 3 dimensions here and then 1 dimension here. I can make something like this. Right, so 3 dimensions for our input layer, so that will be 3 right there. And then let's have a hidden layer of 2, and then 2 here as well for the output layer. Okay. So our labels will correspond to 2 dimensions. It's either a 1 0, a 0 1, and then a 1 0 again for this training data. Okay, just to test if this one actually works. Okay, so go back to our train.cpp file. Okay, so we already read the data from training file, labels file. And then for the actual training part, so we have our neural network right here. Okay. Let's put in an epoch value as well. Right, so how many times the neural network will train until it actually stops? So let's say 1,000 times. 1,000 iterations. Okay, so we have int epoch So instead of hard coding the 1000, this one will be variable to the epoch. Okay. And then at every iteration of the epoch, we're going to be training the input, the target. Okay, our target will be a vector as well of doubles, which we read from our training and labels file. Okay, so we have to declare that first. Okay, so our vector of doubles for training data, and our vector of doubles for our label data. Okay, will be taken from the snippet that we just created, which is to fetch the data according to the path training file. Okay, so this will be utils, namespace utils. Okay, before that we have to make sure that we included the proper header. So we say include so this, our training data will be utils, miscellaneous, fetch data, since this one is a static method from our training file. For our labels data, this will be fetch data from our labels file. Okay. All right. Let's go ahead and review the training process. So what happens here is, right, we perform a feed forward, set up the errors, and then perform a back propagation. Right, so looks about right. So I'm going to remove these logging message. Okay. Right, so we need an input and a target, which we extract from these two variables right here, assuming they're of course of the same size. So for each epoch, we loop through, let's say, the training data. For each t index, for example, t index is less than training data dot size, t index plus plus, and then we train the input. So we have a vector of doubles, which will serve as our input, and a vector of doubles, which will serve as our target. Okay, each of which will be taken from the training data at t index and then here as well, label data at t index. Right, so it will train that and then produce an error. Let's see. Actually, let's have the error at final part right here. We'll say error at epoch I plus 1. Let's just review this. So we loop through the epoch, and at each iteration of the epoch value, we loop through our training data, get an input vector of doubles, get a target from our label data, both of which are read from a file, and then pass it to the training method of our neural network. Do feed forward, backprop, and produce an error here. Let's try this first. Hopefully this works. Let's try to run this. And it didn't work. Alright, let's see why so. Are we still in train? Right, we're still in train. So it printed it out, it created this neural network. Maybe it didn't read the epoch value. Oh, we have epoch right there actually. That's weird. Did I save it? Yeah, I did. Let's remove this. Something like that. Or oh, okay, now I get it. We're actually training the wrong CPP file. Right, there we go. Okay, so we're not using main anymore. We're using train.cpp because again, this will be a separate executable primarily for training. There we go. Hopefully no errors. All right, let's try this out. Whoops. STD out of range. So 322. We never got past the first one. Let's print out the sizes of these. Files. Okay, so it's not reading the label data. As you can see here, label data size is 0. So sample labels, maybe in our config, maybe our config wasn't correct. Sample labels, oh, it's right, so it was named label data. There should be sample labels, right? Sample labels, right? Try this again. There we go. So we can see that I think, wow, we have a lot of, I think this was in the back propagation part, right? So let's just take away the log files first. logging of stuff here. The log printouts rather. So I guess that's about it. All the coutts from our backpropagation part. Okay, so this should just leave the errors, right? Okay, so we have a bunch of errors there, and it seems to be going down, right? So that's good, right? So it seems that our network is actually learning. Okay, so let's go ahead and just print out the errors and see how. Right, so our network is learning. Let's just have the errors printed out instead of having this label right here. Just comment it out for now. And just print out an error. Okay. The reason why I wanted to do that was so that I can config. Let's just set this to 100. Right, so we have 100 iterations. And what I'd like to do is I'd like to copy these values and let's try to graph it. Oh, so small. Yeah, I should probably stream this to a separate file and graph it from there. Okay, how do I graph? Insert chart, line chart. Okay, so that's our error rate, right? From 0.3 all the way down to just above 0.15. So the network is sort of learning, sort of, for this hard-coded data. Okay, but what we want are actual data. So at least we have our neural network already learning, already reading data of a CSV file based on our data right here. What I want is to what I want is some real world data. So I actually did a previous video on vectorizing a matrix. I'll probably reference that video in this. We'll reference that video later on. But basically, we have an image. Okay, taken from the Omniglot dataset, which looks something like this. Okay, I think I used alphabet of the Magi. Right, so essentially what we did is we converted this image into a bunch of ones and zeros and put it in a CSV file. So what I like to do is I'd like to what's the size of this image? What I like to do is I'd like to create a neural network that acts as an autoencoder, meaning the input is the same as the output, and see if it can try to learn just the properties of a single class. I'll show that in a little while later. So it's 105 pixels. So if we vectorize this one will be equal to 105 times 105, 11,025 features of ones and zeros. Okay, so if I were to treat this neural network as an autoencoder, okay, when we want to capture the essence of, let's say of alphabet of the Magi character 1 just for a single label, then it means that the CSV file will measure 1,000. Your input will actually be, was it 1,000 or 11,000? Right, 11,025 characters or dimensions long. Your output will be the same thing. So autoencoder will attempt to reconstruct that, the input. And let's have a hidden layer of, I don't know, let's say something like 5. Just a short one, just to see the process. Of course, we can benchmark this later on, but let's just see if it actually tries to lower the error rate for this one. Okay, and then for the data set, if you take a look at the alphabet of the Magi, for character 1, we have 1, 2, 3, 4, 5, 6, 7, 8, 16, 17, 18, 19, 20 images, yielding a data set of 20 samples. Right, so I have here Magi character 01.csv. I'm going to paste this inside my project directory for an data. Okay. Okay, so you have Magi character 01. Okay, it's just a bunch of ones and zeros. And right, so we're gonna try it out. 11, 25, 5, 11, 025. We're gonna call this Magi character 01. Autoencoder, so it will be the same. The input is the same as the output. Character 01.csv as well. Okay, let's hope this works. Yeah, so oops. Why? Okay, so it's not reading the data size again. So it might be magic. So this one should be Magi. Okay, so you have 446 for the first iteration. Oh, so it's going down. Right, going down more. Okay, so I guess the neural network is learning the essence of the Magi character. Okay, so let's wait a bit until it actually finishes. Actually, let's try to push it more. Let's have a hidden layer of, I don't know, 100. Let's see if this one still works. 100. Okay, so it might take a long time. So while waiting, we're gonna go ahead and create the saveweights functionality of the neural network, wherein we're going to create a function that will write to a JSON file. Okay, so just refer to that. Okay, so this is going to be part of the neural network class. What happened? So I'm going to go move to the header file first. Don't have that method yet. Where should I put it? Okay, probably here. Save weights. Yeah, and all this will do is it will accept a file where it would write the weights to. Okay, and of course, since we're using JSON, we can declare it as a JSON object. Well, actually, this is just the declaration part. Okay, make sure that we're actually including JSON .hpp. Okay. And then in our actual source code, we have here saveweights, string file JSON. Okay, before I forget, we have to make sure that we're using the proper namespace. Oh, we actually did 2 trains here. Yeah. Alright, so we put it here. Okay, so to use that namespace as well, the JSON namespace. And our weight file will look something like this. So it's a vector of doubles. Okay, each element of the outermost vector will be just an array of weight layers, and then inside that will be a matrix. Mic fell. In the form of a vector of doubles. Okay, that's how the implementation will go. Okay, so we're going to get the weight matrix. Forgot what I named it. Weight matrices. Right. This weight matrices dot size I++, and we're gonna push back this weight matrices at I. Okay, and we need to have some sort of method, right? Because this is just a matrix, right? A matrix of values. I can't remember if we did have that. We have to have some sort of method called get values, okay, which will return the values in the form of a vector of doubles. Okay, let's just finish this function first before we try to implement that. Okay, and then for our JSON object, we have JWeights will be equal to weight set. And we're going to go ahead and write it to a file. So stream file something like that. Okay. This was from the old implementation. Yeah, so I guess it's gonna write it to that particular file. Okay, so just okay. So we have to implement get values, which will return a vector of doubles. So in the matrix, let's have here vector double. So mic's falling. Get values. Okay, of course, in our matrix.cpp, vector double get values. It should be a fairly easy implementation. It should look something like this, I guess. Something like that. If I'm not mistaken. I can't remember the. Let's just review this. So get values. IJ. It should be IJ. Or I think it should be something like this. And at each iteration, right. It should be something like this. Temp dot pushback. Store it to temp, and then after we do that loop, we push this back to values. Okay, so temp here represents temp here represents a row of values. We're looping row-wise, column-wise, and we push it according to row call. Right? And then push it to temp, push back temp to values, which will give us our weight matrix. Okay, so let's see if this one compiles. Okay, before trying to compile, again, it's set up in the train program, or rather in the neural network, saveweights function, right? So we have a saveweights, which accepts a file of a JSON file where we would save the weights. And then we have in our implementation, all it will do is it will create a new JSON object, get the weights from the weight matrices, which is a essentially a vector of matrices, stored in weight set. We push it in a key called weights and then write it to a file. So the idea here is, after we train our network, so we'll need a file name similar to our training data and label data. So we'll say weights file, just be weights, so weights file, right? So after training, we'll say something like done writing to weights file. And then we'll call saveweights file before the program actually terminates. Okay, let's see if this compiles. Okay. Let's see. No function call for call to pushback. That's in my matrix implementation. Temp dot pushback get value. What's wrong with this? This looks about right. Why is it complaining? No matching function call. Temp that pushback. Pushback dogwell. It's weird. Okay, hang on. I'm just gonna refer to my old code. You do know it should be as simple as that. Here we go. Oh, it's not in the matrix class. Where could it be? Get values. Maybe in the header. Well, actually, could have just said something like this, if I remember correctly. Because we already had the right. Okay. So we already represented this matrix as a vector of vector values. So actually, we don't even need this. Right? In our header file, we could have just done something like return this values. Right? Here we go. It's compiling. So we compile successfully, and let's just return to our configuration file, and then we'll say weights will be found in the following directory. Weights, let's say magi character 01.json. Right. I believe I called it weights file. Right. So it looks something like that. So let's create a weights directory here. Okay, so yeah, I guess this will do. Just to make sure that it's already working, then I'll just set this to 5, with just an epoch of 5, or even just 3 rounds, right? Just for the program to actually finish and try to write the weights, the trained weights in a saved file. Okay, so just to review, we have a separate function called train, or a separate program called train, which accepts a config file in the form of JSON, which you read through the JSON Cpp library, just a single header file. We get the parameters. Of course, we parse it first from the file, get the parameters, okay, location of the training data, location of the label data, where we would save the weights, learning rate, momentum, bias, print out the topology, create the network according to the parameters, training data, label data in the form of vectors, vector of doubles. Now, for actual real-world data, we might not be able to do it this way, right? Wherein we store everything in a single structure, in a single vector of vector structure. But I actually did this to work on my PhD, so wherein I tried to solve the problem of one-shot learning, wherein you just have small amounts of data but still have an accurate model. So I guess this data structure will hold, because I just need a few data, sample data, and it should be able to produce some sort of accurate model using neural networks. But in any case, we start in these variables, we loop through the epoch counter, which we also take from the configuration file, loop through the training data, perform the train, print out the error. Once training is done, then we write it to the JSON files using our saveweights function. Okay, so try this out. Only 5 rounds. Shouldn't take too long. Okay, so done. It wrote the JSON to this file. Let's just check if we actually have that file. Okay, so we have it here, and we have our weights. Okay. So now that we can actually save the weights, then next step would be to train the data set and then try to perform classification by implementing a load function. So I'll be creating another program that performs classification that will read through these weights, saved weights file, right? But for now, I guess that's it. And yeah, we'll end with that.